Hello everyone, I'm Wang Leiming and welcome to my video. Today I would like to introduce my final year project 1, which is Privacy Preserved Process Estimation. At the beginning of my presentation, I would like to introduce the development of AI technology. Convolutional neural network has raised people's awareness when AlexNet wins the ImageNet competition in year 2012 for the image classification task. From that year on, convolutional network has kept evolving and has its huge impact on computer vision area. The below pictures show the evolution process of convolutional neural network. The left one is AlexNet, in which it only has some convolution layers, max pooling layers, and fully connecting layers. However, the right-hand side picture shows ResNet, which has more complicated structure. It has many stages and special structures such as residual block and many more convolution layers. The evolution of convolutional neural network also has its impact on action recognition. And here I would like to introduce its background. By using convolutional network, we can achieve skeleton extraction. Joins of data can be got. It can be clearly seen that the skeleton is composed of joints and lines. And the joints are always critical points, like people's shoulders, head, knee, and foot, something like that. And lines are just the straight lines connecting the joints. So it's just basically a tracking task for predict the joints in a human. And the next stage is behavior prediction. After we get the skeleton, we can apply it for predicting the behavior. However, the main issue of deep learning task has also raised, since deep learning has two characteristics. First, the neural network becomes deeper and deeper. Since more parameters can help people predict more complex tasks, researchers are always seeking more complicated neural network to deal with more challenging issues. The second characteristic, which is important to this presentation, is massive amount of data, since deep learning needs many data for training. But it also raises the security and privacy issues. Massive personal data is not easy to avoid attacking, since the amount is too big and hard to manage. And the many personal information can have huge impact for people. Take the Facebook Cambridge Analytica scandal as an example. Facebook company has sold his user personal data to Cambridge Analytica company, and this company make use of this privacy data to conquer the American election of president. So it has very bad impact. Therefore, it's very important that massive amount of data should be properly controlled. For action recognition task, privacy issues has also raised. For example, in the left-hand side picture, we can clearly see this person's personal information such as facial information and dressing. Therefore, its privacy problem has also raised. In order to deal with that, our team came up with a solution in which depth and thermal data is applied. We can see the depth and thermal data that the facial information can't be seen, and the dressing is also vague. The only thing visible is the human's profile. So in this way, the privacy issues seems to be solved. But you may ask if some important information is lost if we don't use RGB 3-channel data. I would only say that if we can combine the strength of depth and thermal data to have a combination prediction score, we may at most have the same prediction result as RGB data. So here is our work. We first collect the UT Kinect Action 3D dataset for our training. This dataset consists of 3 channels, which is RGB, depth, and joint. And it has 20 joints for each picture, having X, Y, Z 3D coordinates. Then we find the proper training model, which is Microsoft baseline model, and it uses PostResNet 50 as its backbone. PostResNet 50 is only a little modification of ResNet 50, and it has sample MTII annotation scale, which is 16 points, and XY coordinates. To complete our training, we should first implement depth image conversion. Depth image for UTK dataset is saved as XML format, so it only contains some distance matrix. So it's clearly saying that we should make some conversion to transfer it into .jpg format. So typically we just apply data nomination to limit the data from 0 to 1 and do channel duplicating. Finally, the depth image is made. Then we should convert the UTK annotation to MP2 annotation. The right picture shows the UTK joints, and it has 20 joints when MPII only has 16 joints. So UTK has some transformation. And MPII also has its own parameter center and scale, which needs calculation. Detailed calculation are listed in paper, just some math transformations. So here is our pipeline for training model and make prediction. The above shows UTK RGB image after training. It got post-ResNet training weights, and we apply transfer learning for UTK depth image, and finally get the depth skeleton extraction model. Therefore, by using the arbitrary depth data, we can do depth skeleton extraction to get the joint position, and finally use STGCN technique by skeleton to get the action prediction. Here is our model training result. We have hyperparameters for 1050 approach and 32 byte size. After training, our loss achieved very low and achieved 99 accuracy. The difficulty for implement the project is by modifying the PyTorch project. We should initialize a PyTorch dataset class, and we should use getItem function to get the input. And the interaction of different project files is also difficult, like config py to save hyperparameters, init py to get the initial class. These are all important. And the last difficulty is .yml file saving hyperparameter. We should make use of that. The future direction of our task is first giant analysis for scaled data. And we can also use skeleton STGCN technique to predict action from scaled data. Third, we can capture depth data ourselves to train our model. Last, we don't get any thermal data as well, so we should try to do that. That's all for my presentation. Thank you.